Like any star, it will run out of fuel in its core, and it starts changing. It starts bloating. And getting so large that it will engulf the orbit of Mercury and Venus and come very close to Earth. So imagine looking on the horizon and sunrise is half the sky. Okay, that would be terrifying.
Betelgeuse, also known as Alpha Orionis, is one of the most famous stars in the night sky. It is a red supergiant star located in the constellation of Orion, and it is easily recognizable as one of the brightest stars in the sky. Known for its mysterious behavior, Betelgeuse is also called a variable star because it pulsates, expanding and contracting in size over time. This pulsation causes the star's brightness to change, sometimes making it one of the brightest stars in the sky, and other times causing it to dim significantly. But the real mystery that had astronomers on the edge of their seats was the star's unprecedented dimming event late in 2019 and early 2020, as the star experienced an extreme dimming, losing a significant portion of its brightness. This sparked speculation and curiosity among scientists around the world that Betelgeuse might explode. Several theories were proposed to explain the dimming, but one particular possibility stood out and was later confirmed by the Hubble Space Telescope. Based on data from the Hubble, scientists discovered that Betelgeuse had ejected a massive cloud of dust, partially blocking its light from our view. However, since the dimming event in February 2020, the star has not repeated this cycle. What we now know is that the star recovered from expelling a huge amount of its inner material during the Great Dimming. Its surface started behaving like gelatin on a plate, bouncing and fluctuating. Additionally, Betelgeuse has lost its usual 400-day pulsation rhythm that had been observed for at least 2 centuries, adding further intrigue to its enigmatic nature. Betelgeuse is an absolute giant with a diameter over 1,000 times that of our Sun. To give you an idea of its size, if we were to place Betelgeuse at the center of our solar system, it would engulf the inner planets, including Earth, and stretch all the way up to Jupiter. Its immense size and mass classify it as a red supergiant star, indicating that it's nearing the end of its life. However, with a distance of less than 700 light-years, it's much more likely that we might witness its demise in our lifetimes. Traditionally, astronomers have suggested that Betelgeuse might explode within the next 100,000 years, which on a cosmic timescale is considered relatively soon.
Is this even starting to happen?
No, not yet. No, we have another several billion years. So if you're going to prioritize...
Well, that's all right. That's a dropped intro, isn't it?
But from a human perspective, this time span might be disappointing, as it extends far beyond our lifetimes. And many people want to be around to witness this event. Surprisingly, we're now hearing that recent calculations and a study conducted by Hideyuki Seo and his colleagues from Tohoku University in Japan propose a different possibility. Their research suggests that Betelgeuse might be more advanced in its evolution and closer to the brink of a supernova explosion than previously believed.
So what do you think this is, or what could it be?
They are among the biggest explosions of radio energy in the entire universe. They generate more energy than 1 billion suns. The energy in radio frequencies is so great that eventually the entire universe will be aware of this one explosion.
This new study raises the exciting prospect that the spectacle of Betelgeuse going supernova could occur in our lifetime, potentially unfolding before our very eyes. It could explode right now as you're watching this video. Hideyuki Seo and his team have been studying Betelgeuse's unique rhythm. This star doesn't stay still. It expands and contracts regularly, much like a giant cosmic lung taking breaths. These breaths cause changes in the star's brightness, which astronomers have been tracking for over a century. They've noticed several rhythms in the cosmic dance, including cycles of 2,200 days, 420 days, 230 days, and 185 days. Most astronomers have traditionally seen the 420-day cycle as the star's main rhythm, with the shorter cycles adding extra beats. If this is the case, Betelgeuse would be so huge that if it were in the place of our Sun, it would stretch almost to Jupiter's orbit. That's like lining up 800 to 900 suns. But Seo's team had a different idea. They suggested that the 2,200-day cycle, which lasts about 6 years, might actually be the star's main beat, with the other cycles adding extra rhythms. If they're right, Betelgeuse would be even bigger, spanning the width of 1,200 suns, easily outstretching Jupiter's orbit. This would make Betelgeuse an even more massive and fascinating star than we previously thought. Considering the larger size of Betelgeuse, it would be further ahead in its life cycle of fusing elements than previously thought. Stars like Betelgeuse have a fast and massive existence. Initially, they ignite by fusing hydrogen into helium within their cores, but they quickly progress to fusing helium into carbon. Subsequently, carbon undergoes fusion to produce heavier elements. Betelgeuse, being a red supergiant, is estimated to be at least 8 million years old and is believed to be in the final stages of its life cycle after burning through the hydrogen in its core. In the outer layers of the star, lighter elements burn in shells, causing the star to expand outwards, resembling a hot plasma balloon. Hideyuki Seiyo and his colleagues employ computer simulations to observe the evolution of stars from birth to old age. They calculated the expected pulsations at each stage of the star's evolution. Through their simulations, they find that all 4 pulsation cycles, ranging from the 2,200-day period to the 185-day period, can be explained by a star in the late stages of carbon burning, resembling a breathing phenomenon. The researchers indicate that after the carbon in the core is exhausted, a core collapse leading to a supernova explosion is anticipated within a few tens of years. However, it is challenging to determine precisely when the carbon will be depleted, because the pulsation periods do not significantly change during this late stage. Seiyo notes that it's difficult to estimate the exact amount of carbon remaining in the core at present, but they speculate that the time until carbon exhaustion is likely less than a few hundred years, and what we will witness would be a spectacle of the millennia. But there's more, because as the star pulsates like a balloon, inflating and deflating evenly in all directions, a very special phenomena known as radial pulsations drastically influences the behaviour of the star. Interestingly, Betelgeuse isn't just pulsating at any speed, it's moving incredibly fast, about 1.5 kilometers per second. To put that into perspective, it's faster than a high-speed train, which can reach up to 3,300 miles per hour. So what happens when this fast movement continues over the 2,200-day cycle? The star's size changes dramatically. It grows and shrinks by a size equivalent to 180 of our suns during each cycle. Imagine our sun expanding up to 180 times its size and then shrinking back down over and over again. That's a pretty big change, even for a star. But there's more. The 2,200-day cycle also influences the star's other pulsations, like the 400-day cycle. When Betelgeuse is at its biggest, the 400-day cycle takes longer. When the star shrinks, the cycle gets shorter. You'd expect these changes to happen every 2,200 days. However, researchers haven't seen this pattern in Betelgeuse's brightness over time. Instead, it seems to vary more randomly around the typical 400-day cycle. This adds another layer of mystery to this intriguing star. When a star like Betelgeuse exhausts its hydrogen fuel, the helium begins to fuse into carbon. This process causes the star to expand, much like a balloon filling with air. But as the fuel depletes and the remaining elements can no longer sustain fusion, the star's core succumbs to its own weight and collapses, forming a dense neutron star. This collapse triggers a rebound of the surrounding gas, resulting in a supernova explosion, a cosmic spectacle of immense proportions. This explosion will release an intense burst of energy and light, causing Betelgeuse to briefly outshine all its stellar neighbours. The resulting brightness will be so extraordinary that it will illuminate the sky for an entire week. The supernova could even be visible during daylight hours, outshining the moon's glow, as reported by The Guardian. This awe-inspiring display will provide a rare opportunity for astronomers and stargazers alike. Now, while Seiyo's group is not suggesting that Betelgeuse will explode tomorrow or even within the next decade, their claim is that Betelgeuse is expected to go supernova within 1,000 years, which is a shorter time frame compared to the previous estimates of 10,000 or 100,000 years. So, are you excited to wait 1,000 years for Betelgeuse? Let us know in the comments.